Welcome, dear learners, to this session on graphical representation of data. In the last session, you were told about the tabulation of the data, and in this session, we are going to discuss how to represent data in graphical form. So in this session, we are going to summarize percentile and percentile rank, which we also discussed in the last session. We will describe bar graph, histogram, frequency polygon and cumulative frequency polygon, and also explain the steps in construction of a pie chart. So this is also related to the last session on tabulation of data, because there we discussed about how to calculate cumulative frequency percentage, and so on. So now let us begin. Before we go on to the graphical representation of data, I would like to just summarize on the percentile and percentile rank, which we discussed in the last session. Percentile actually, it helps in comparison, and you must have come across the word percentile many times. However, you should not be confused with percentage. It shows how a person or an individual stands with reference to other candidates. For example, in many of the competitive exams, we get to know about the percentile and the percentile rank. So that does not mean a percentage, 99 percentile. So that does not mean that it is a percentage. It is calculated with the help of a formula, which is like number of values below x, and x is that value, x is that percentile, total number of values divided by total number of values into 100. So again, when we calculate it this way, it is the ratio. So actually we are calculating the ratio of number of values below x. So for example, a person who scores 70, how many values are below? If a person secures percentile of 70, how many values are below that 70 to the total number of values? So in other words, it can also be small n divided by capital N into 100. So because we are going to calculate the ratio, so it will be on multiplied by 100. So small n here is the ordinal rank of the given value or value below the number, that particular number, and the capital N here in this formula indicates number of values in the data set. So we actually know how many people appeared in that exam, so how many values we have in that complete data set, right? And capital P stands here for percentile. So rank will be percentile upon 100. So if we take a small example here, the data set is like 30, 35, 39, 58, 61, 68, 71, 78, 83 and 92. Now these are the scores. For example, an individual has, there are candidates who have scored these, and we would like to calculate the percentile for the score of 78. So how it goes? Number of values, if we see the formula, number of values below x. So x here will be 78, because we are calculating the percentile for 78. So how many values we have below 78? We have the entire data set has got 10 values. So below 78 we have got 7. The total number of scores we have 10. So what will it be like? It will be 7 upon 10 into 100, right? So that is the ratio. So that is the particular one value against all the values. So that is the ratio of that particular value for all the values. So it will be 0.7 into 100, and so the score comes out to be, the percentile comes out to be 70. So this is the 70 is the percentile of the candidate who has scored 78 marks. So in a way, this is how we compute percentile. Now we will move forward towards the graphical representation of data. Now, graphical representation, as the name suggests, we represent the data set with the help of a graph, and it is very important, like when we discuss the tabulation, how important it is to tabulate the data, because the data in the raw form does not communicate any meaning. It is in fact meaningless. So we need to tabulate, we need to find out the class intervals, we need to find out the frequencies, right? Again, like for example, in one particular data in that category. However, in we can, the same tabulation we can also graphically represent. And when we graphically represent a data, it becomes very, we are able to understand it. It becomes very easy. It also becomes very concise and attractive. When you see various graphs, like for example, in various reports, like for example, in economic survey, WHO report, UNDP report, UN reports, and National Health and Family Survey, Census of India, we come across so many tabulations. We also come across graphical representations of data. So the data becomes automatically very concise. You can comprehend it just by seeing the graph. You can interpret the result also, right? It becomes very attractive. It becomes easy to interpret. Comparisons can be made. You can, for example, we will just see how it goes. You can very well compare, for example, the performance, productivity, the various production in the industrial sectors, right? So we can make comparisons. Comparisons are very easy to be made through when we represent the data in the graphical form. Some of the important graphs that we are going to discuss will be bar graph, histogram, ogive, pie chart, and so on. Now, bar graph, this is one of the most common form of graphical representation, and in fact, it is most widely used. You must have also come across this, you must have seen it in many reports, and in fact in many of the textbooks also of various courses, because these graphical representations, these are used across the disciplines. It is not only in psychology, but it is used in, you can use it in sociology, in economics, and in sciences. See, these are in geography and so on. It is the graphical representation. These are the various forms which can be used across disciplines, and it is common for all the disciplines. So here, and it is one of the most, bar graph is one of the most widely used graphical representation, and they are rectangular bars. Length of these bars should be proportional to the numerical values represented by them. So we have a data set actually. So according to the data set, we said the length of these bars, it should not be disproportionate, right? So the length and the width has to be decided beforehand. And they are plotted either horizontally or vertically. And as we know that it can be plotted on a graph, and now we have, the graphs are also plotted with the help of softwares. We have x-axis and y-axis. So this is very important. We set some value on the x-axis, that is the horizontal line, and the y-axis, that is the vertical line. So we have to select some kind of data set that will be reflected on the x-axis, and one of the data set will be reflected on the y-axis. And accordingly, the labeling is done, and accordingly it is drawn. We will see how. Now this is just a demonstration of of a bar graph, and these are the steps how to construct a bar graph. So for example, on the left hand side you see a demonstration. We have the marks obtained on the x-axis, we have number of students on the y-axis. So this has to be decided, okay? And then the vertical x-axis and the horizontal y-axis, they should be perpendicular. This is one thing. We have to label x-axis and y-axis. We have done it here. And a scale needs to be selected for the length of the bar. So it has to be proportional. It should not be disproportional. Otherwise, the data will not be represented properly, and it might not be also appealing. So, and the width of the bar and the gap between the bars should be uniform. This will be selected by the person who is representing the data. So this also has to be uniform. Among all the bars, for all the bars, this size, the width, the length has to be taken into account. And accordingly, the graph will be drawn on the basis of the data. So, for example, here we have the scores. These are the particular, for example, the class intervals, and accordingly the frequency, the marks obtained in each category, this is one of the most easiest form of graphical representation that is done. Followed by it is histogram. Histogram is also a kind of a bar diagram. You know why we say? Because this is bars, these are the bars that are represented. So this is in histogram also, these are also bar diagram, but what is important here is the frequency distribution, right? So for group frequency distribution, class intervals are important. So we also discussed about the class intervals in the previous sessions, and it can be inclusive or exclusive. So for frequency distribution, it is important to find out the the class intervals, and we need to decide upon the lower class, the lower limit and the upper limit, right? So the lower limit of the class intervals is plotted on the x-axis and the frequency on the y-axis. So if we compare it here with the bar graph, we have these scores. Actually, the one particular, there is no category as such. Of course, we have and we have the number of students falling in that bracket of the marks obtained. But here it becomes little complex, because here we are taking into account the frequency distribution, right? So the frequency distribution, we will have to categorize into class intervals, and we have to take into account the lower limit also. Say, for example, this is, see how it goes. Now the actual lower limit of the class interval is considered, and on the y-axis we have the frequency, right? So histogram is based on the frequency distribution or the group frequency distribution and has class intervals primarily. So this becomes little complex than what we did earlier, that was the bar graph. So before constructing a histogram, two more class intervals are added, one below and one above. And this is the way. Say for example, the main data is from 20 to 29 to 60 to 69. This is the class interval. But now we are selecting one above and one below. So for example, we have selected 10 to 19. And then one above, that is 70 to 79. So this is important. So this data has to be this table. We need to compute the class intervals, and against them the frequencies in each class interval. This has to be decided, and it has to be kept ready before we plot the histogram, right? So that is important. And for example, the class interval is changed for 10 to 19. It is like, for example, 9.5 to 19.5, right? So it is 9.5 to 19.5. So here again, we have to take care of what kind of class intervals we are deciding, the lower limit and the upper limit, inclusive and the exclusive categories. So we have to decide on that. So on the x-axis, the actual lower limits of all class intervals are then plotted. Now we see that the lower limit is plotted on the x-axis, right? We can see it is 19.5 and 9.5 and so on. So the frequencies are then plotted on the y-axis, right? And a single rectangle then represents each frequency. Now, whatever the frequency is, these bars, these rectangles are representing, and there is no gap between. There is no gap between the bar, right? There is no gap between the bars as we saw it in the bar graph. So here, what is important? The basic difference between bar and histogram is, like bar graph and histogram is frequency distribution or a group frequency distribution. We are going to compute class intervals. We are going to decide the upper and the lower limit. And accordingly, the lower limits are then plotted on the x-axis and the frequencies on the y-axis. So these are actually very simple way of representing our data graphically. And this is the data set. So we can have any kind of a data set for this, right? The third important graphical representation is a frequency polygon. Now, frequency polygon is basically a line graph, and it is used to plot frequency distribution. Again here, frequency distribution becomes important. So when frequency distribution becomes important, we also need to compute the class intervals. So now you see, it is all related. The tabulation and graphical representation of data, they are interrelated, because there we try to find out, we draw how the class intervals, the midpoints, or the lower limit and the upper limit. So now this becomes important when we graphically represent the data. So in frequency polygon, the midpoints are computed for all the class intervals. Again, x-axis and y-axis become important. On the x-axis, what we are going to plot? We are going to plot frequencies. And on the y-axis, we are going to plot the midpoints of class interval. And then the midpoints of these corresponding frequencies, they are joined to form a line. So basically, what we are seeing here, frequency polygon is basically a line graph. As of up till now, we have seen in the bar graph and the histogram, they are rectangles. However, in frequency polygon, this is a line graph. We will see how. Now you see a line graph here. You must have come across such type of line graphs in economic survey and various other, like for example, various reports also. Now you see here also, this is based, again, this is based on frequency distribution, and here also two class intervals are added. They are one below and one above, right? As we did it in histogram. See, we have taken one above and one below, 10 to 19 and 70 to 79. We have added two more class intervals, and the frequency stands as 0. So the main data set is between 60 to 69 to 20 to 29, and we have various frequencies in these categories. And then we are supposed to find out the midpoints of these class intervals. Say for example, for the 60 to 69, we find out the midpoint. Similarly, for 50 to 59, we find the midpoint as 54.5, 40 to 49, it is 44.5, and so on. Right? So here what we are seeing the midpoints on the x-axis. We are seeing the frequencies for that particular class interval on the y-axis. Say for example, for the category 60 to 69, we are seeing that the dot is placed on 10. Right? So and then for the last class interval, 70 to 79, the midpoint comes out to be 74.5. However, the frequency here is 0, and so it touches the baseline. That is the x-axis. And similarly, for the interval 10 to 19, again we have the midpoint to be 14.5. You can see on the extreme right, and then again here the frequency is 0. So again it touches the baseline, that is x-axis, and in this way a line graph is computed. So the points are then, when we plot the midpoints, these midpoints are joined actually, and thus it forms a line which connects all the midpoints of all the class intervals. However, it should be kept in mind that about the height of the graph. This is important, otherwise it becomes very disproportionate. So it should be 75% of the width. So these few things are important while we are constructing histogram or a bar graph or a frequency polygon. That ratio, that proportion, the height and width should be proportionate. That is, we should take care of that while we are plotting. This is actually frequency polygon with the help of a histogram. Now this, we just discussed histogram. So in this also, when we draw frequency polygon as discussed, we chalk out the midpoints. We can see it, this is a frequency polygon on a histogram. It is similar to this. It is similar to the right hand picture. However, in this only the difference is we also have a histogram. So we can always plot, if we go back to the histogram, it can be plotted on this as well. The frequency polygon can be plotted on this as well. See, we can plot the midpoints, and then the the one above and the one below class interval, it will be 0, and then a line graph can be drawn. So a frequency polygon can be drawn with the help of a histogram also. Now we have cumulative frequency percentage curve or the ogive. Now the cumulative frequency percentage, we know how to calculate cumulative frequency, and following which cumulative frequency percentage. For example, if you have a data set, we have frequency. We can, on the basis of frequency, we can calculate cumulative frequency, and on the basis of cumulative frequency, we can calculate cumulative frequency percentage, right? So if we want to plot cumulative frequency percentage, it can be plotted in form of a graph, in form of a line graph, and this is known as ogive. So what we have here, also we have x-axis and y-axis. On y-axis, we have cumulative frequency percentage. On x-axis, we have the upper limit of the class intervals. So if you see from these graphical representations, that class intervals is important. Deciding on the upper and lower limit is also very important, because, for example, in histogram or in the frequency polygon, we have class intervals, right? So when we are plotting cumulative frequency percentage curve, so what is important? We need to first, as in histogram, here also our table should be ready. So we should first calculate the cumulative frequency percentage, and we should also decide upon the upper limit of the class intervals. So the points on the cumulative frequency percentage are then joined with the help of a line. This is also very simple graphical representation. However, in this, one thing is important, that it does not have a negative slope. We will see how. It does not reflect a negative slope. And if the class interval has 0 frequency, then the line will be horizontal. This is also important. We will see how. Now, you see, whatever we have, for example, we have this data set. You can have any sort of data set. Here, the class intervals start from 10 to 19. They go up to 60 to 69. We decide upon the upper limit of the class intervals, right? The upper limit and the lower limit as per the exclusive or the inclusive class intervals, right? So we decide upon the upper limit. So here it will be 69.5, in the next it will be 59.5, then in the third it will be 49.5, and so on. Now already this we are going to calculate. However, already the frequency will be given. See, it will be 10, 12, 30. Now this is a data set. The class interval and the frequency is already given, right? Now on the basis of this, we are going to calculate cumulative frequency as we did it in the tabulation, right? So here, if we start from below, it will be 0, 0 will be 0, then it will be 5. If we plus 5 plus 4, the frequency of the class interval 20 to 29 added with 30 to 39, it will be 9. And then 9 plus 13 will be 22, 22 plus 12, 34, and so on. So the last cumulative, we are going to add up, summate all the frequencies, and the last one becomes 44, right? Now what is happening is, in the last column, so this should be actually ready when we plot the curve. The last column reflects cumulative frequency percentage. So as the name suggests, percentage. So this is on 100, right? So now we know that the total frequency, even if you add frequencies 10, 12, 13, 4 and 5, it comes on to 44. Okay, so the cumulative frequency is 44. So the 100%, the cumulative frequency will be 100, because what we are going to do, 10 upon 44 into 100, it will be 100%, followed by, and in a similar way, we are going to calculate the percentage of cumulative frequency, that frequency amongst all the frequency, right? So for the 50-59 class interval, it will be 77.27. For the 40 to 49 class interval, we have 13 frequency. So we know that the cumulative frequency here is 22. So the half of that is just the half of 44, and it is coming to 50%, right? So this way we are going to calculate this category, that is the cumulative frequency percentage, and accordingly we are going to tabulate it, right? So we are going to plot it on a graph. On the y-axis, we see the cumulative frequency percentage, followed by the on the x-axis we have the upper limit of the class interval. We see on the x-axis we have the upper limit of the class interval. So this is how we plot ogive, or the cumulative frequency percentage curve, and this is very important for many of the data sets. So this is how we are going to calculate. Just to recap, the frequency distribution table should be ready when we compute the cumulative frequency percentage, and the cumulative frequency percentage is plotted on the y-axis and the upper limits on the x-axis. The points representing the cumulative frequency percentage for each class interval is then plotted, and then these points are joined with the help of a line. So in a way, it is a line graph, but it has no negative slope. This is important for an ogive. Last, we are going to discuss about the pie chart or a circle graph. This is a very important graphical representation. However, it is very easy to compute or to plot. So actually, it is a circle which is divided into various sectors, and you must have come across a pie chart often in the reports. Now, these sectors, they represent the numerical proportion of the data. Now, there are sectors actually, and the circle, as we know, there are 360 degrees in a circle, and in that circle only, we try to compute the sectors. Now, the sectors are calculated with the help of the formula, that is the frequency of the component divided by total frequency into multiplied by 360, because it is the 360 is the area, right? If the components are presented in percentage, you know, when we come on to percentage, it is always on 100. So here, then the formula becomes percentage value of a particular component divided by 100 into 360. So here percentage, if the percentage is given, accordingly it will be on 100 and multiplied by 360, 360 being the area of the circle. And when we want to calculate the sector, so the frequency will be given in the data set. We are going to divide it by the total frequency and then multiply it by 360. We are going to see how. For example, this is the areas or the sectors in a pie chart. Okay. So here you see lawyer, accountant, psychologist, engineer, doctor, right? Now these are the sectors. You can see, you can translate into various other, for example, productivity, or the kind of, for example, in industrial settings also, and in various other areas, pie chart is applicable. So the data represented here is in 360 degrees because the area of the circle is 360. And the total frequencies also will be equal to this only. So the angle for each component, because how we are going to plot these sectors? We are going to plot these sectors by taking out the angle, primarily an angle. So frequency of the component divided by the total frequency into 360. So these sections are then drawn after the angles are computed, and we will see how. So for example, this is a data for the pie chart, right? We have, if we refer to this example, we have lawyer, accountant, psychologist. You can take any of the, for example, crop production. If we say have wheat, rice, tea, and so on. So, and accordingly, it can be, as per the production units. So here we have number of individuals. So in the lawyer category, we have 5, accountants 6, psychologist 4, and so on. The total frequency or the total number is 30. So now how we are going to compute the angle? Angle will be the frequency for that particular category. Say for example, lawyer. If we want to calculate the angle for lawyer, for that lawyer sector, it will be 5 upon 30, 5 divided by 30 multiplied by 360. So we have 60 degrees. So we can then accordingly, we can plot it on the graph. So it will be 60 degrees, right? Similarly, for the accountant, it will be 6 divided by 30 into 360. So this will be 72 degrees. So in all, what if we want to counter check it, the addition of all these angles should be 360. So that is 60 plus 72 plus 48 plus 84 plus 96 will be 360. So this is, we can check whether the sectors, whether the angles have been calculated properly or not. So in this, we have covered the bar graph, histogram, frequency polygon, with then ogive and the pie chart. Dear students, all these methods of graphical representation are very important, and it also depends upon what kind of data set we have. At times, pie chart can be useful rather than a bar graph, or a histogram is important than a pie chart, or a line graph to represent the particular set of data. So, as per the what you want to represent, how you want to make the interpretation, accordingly, that method, that technique will be used for graphical representation. Thank you so much.